Hey, we didn't have Cavalier. He was here before Dr. West. Yeah, Cavalier was here for me and Brett. He was high career, I think. Here. He went off for grad school. Yeah. I don't know if he was here longer. In fact, I don't know when he was made.
Back when it was founded.
I know he was. There's a Mason stamp down there. It's like 1930 something. Yeah, I would get pictures of him. I wish I had him. Hey, I see you too, buddy. Oh, there he is. He's behind you.
How you doing, Matt?
Hold on, Clay, you're hiding. Hold on. There you are. Hey, Larry.
Hey.
You look good, buddy. You look good.
No, I'm deathly sick, man.
You're on mute.
I'm deathly sick.
Oh gosh, he's sick. He's got the heat on.
Yeah.
Oh, he's sweating.
It's been rough on the mountain.
Can't hear you.
Can you breathe, Clay?
I can breathe. Can you hear me?
Speakers up there. Let me try that. Yeah. You might connect to the speakers. Dr. Watson is having issues too with hearing that. Like the speakers of the projector. Yeah, like I don't.
Huh?
I don't know. I assume because sometimes points of those. I don't know. Okay, guys, let's start. So today we will continue our previous exercise. There's a part that we left behind, small part, and to continue working, there's another exercise. Looks good, but it's really small thing that we did before. It's part of the orthography. So let's go there and start. And we have here our Zoom people. They turn off their cameras. They can hear us probably, but we cannot hear them. So if you remember, guys, we created a map last time that used 3 different types of projections. They're all conic projections, which is what conic. And we used a specific projection for Alaska, another for Hawaii, and the third one for the main continental US. Today we're going to do an exercise that's smaller than what we did last time, which is called here the Colorado counties. And here we're also going to show you how does the computer try to figure out if we do not have a projection or the projection is wrong, how so let's directly go and continue our exercise here. Get this one. Oh, that's seriously. So what we'll do right now is that we will go to our I'm gonna share my screen with the guys here. So let's share the screen here. Okay, so now directly let's go to our ArcGIS catalog and figure out what we have here. And just follow my guide here, and then we're gonna answer the question. So what I want you to do, once you start our catalog, go to the same folder of data that we downloaded last time, and let's open the C file. We have A, B, and C only. So let's just give it some time to open. So just double click on EX0C MXD file in your folder, the one that came with your zip file that you did last time. So if you start this one here, so once you double click here on this, probably it's going to give you the same problem here. So again, you open the EXC file, the X46C file, the map file. It's going to give you something like this, two other frames, and one frame is state plane, and the second one is called UTM, the things that we did in class just yesterday. And probably the links will be also corrupted. I'm going to fix that. I'm going to fix the links here. So let's do this together. So I'm going to click on each one of them here, right click. And under data, I'm going to repair the data source. So again, you right click on the layer that has a corrupt data path, and you just go ahead. And since it's the US states, I'm gonna pick this guy here, and it's gonna fix now the two. So it looks here that we have, I think, the state of Colorado shown in the two frames. One frame has a specific coordinate system, and the second frame has another coordinate system. Let's test it, guys. Remember how did we test the frame coordinate system? I go here, properties, and you notice here the coordinate system is state plane Colorado Center. So here we touch base on another coordinate system. We haven't had the chance to discuss it yet in class. However, you easily understand, and you had it in your surveying class. And also, if you had read the chapter in coordinate system, you're gonna definitely read section about state plane coordinate system. So here, this is the system specifically for one zone in Colorado, which is the Colorado Central State Plane, and that is the name of the coordinate system. Let's go to the other one. So I go to UTM, properties, and you can see now the coordinate system here is called the UTM Zone 13N, the one which has Colorado in the west. And let me now here specify a difference. What we did last time is most probably that we looked at the coordinate system within our catalog. This is the coordinate system of the data. Here what I'm seeing is the coordinate system, what I'm seeing right now in the map. Sometimes the data comes in a different coordinate system and it does this kind of projection on the fly, just so you can see it. And here what I'm, even the data is different. Here you can see the same type of data, the same shape, but two different coordinate systems. Let's now figure out what is the coordinate system of the data. Remember we did this last time? So I go back to catalog and again go to US states and properties. So it's completely a different coordinate system. So I want to tell you something here. The data is a geographic coordinate system called GCS. It has longitude and latitude. When we threw it into two different frames, it was drawn over on the fly and it was projected on the fly in two different systems. One was UTM and the second was state plane coordinate system. So, and this is the beauty of GIS. You can still use the data in one system, but it's projected on the fly two different coordinate systems. You guys, any questions here?
Oh, no, you're good. It should yeah, it's showing his ultra.
No, you want to fix the tab.
I know, but I selected all of them.
You like? You want
Because
to?
it's one of them, so I just picked them all.
Okay.
But yeah, I don't know why I didn't want
Okay. Now, question number 3 here. Let's now try to add Colorado counties to the state plane data frame. Right and snap what happened. So let's do the following. And before you click, so here cancel, put the side, and take this on the side. Let's cancel. Just gonna put them side by side. So now, what you want to do, guys, is get the Colorado counties. Let's remember what's the coordinate system of the Colorado counties. So let's, before we carry it there, I'm gonna go to the Colorado counties, right click, properties, and if you remember, unknown system, it's gonna create a problem. So we know that already, and we try to fix the problem. And we did that last time. And then let's now take this Colorado system here, Colorado counties here, and I want you now to snap this, this error message. And it says the following. The following data sources you added are missing spatial reference. Has no spatial reference. It's just some data with no spatial information. This data can be drawn in ArcMap, but cannot be projected. So I'm going to draw it. I'm going to try my best. The computer is telling you that, but I'm not sure if it's going to go in the right place or not. So click OK, and let's do the same for the other frame. Same thing. And I'm just going to put here Colorado counties above, because the counties is smaller than the state, so we don't need the states to cover it. So I just arrange the layer above each other so they can now answer this question, guys. You're going to do it, not me. Locate the location of Colorado counties and answer the following. Where were the Colorado counties located and what caused the problem? Let's do it in the both layers. Again, the both frames, we put the Colorado counties layer. The computer said, I will try to find it for you. I'll try to project it my own way. The computer will try to outsmart us, and it will be somewhere. If you look here, now let's get back to the complete map. This is Colorado. Colorado counties don't show anywhere. in both of them. So I'm gonna zoom to the layer, and you guys answer the question, guys. Where was Colorado located? The county is located. So I'm gonna go here first. Right click, zoom to layer. Right click, zoom to layer. And to here we layout view. Layout means printing view. If you want to go and look at much better way, go to data view, figure out which frame you want. Go to data view. Data view is this guy here. This button here on the lower left hand side. And this is Colorado. I zoom to it. And it's somewhere. I don't know where it is. You probably know better. Somewhere. So write in the answer, where did ArcGIS throw the Colorado counties? I'm going to fix that in a second. And also, let's go here, UTM. Let's activate this one here. And let's zoom extents. Let's go back. So for one side, it was thrown somewhere. In the other UTM system, it was thrown even somewhere else in the middle of nowhere. So for the state plane, where was it thrown? It was thrown somewhere close because in the state plane system, it focuses only on the US. But the UTM, it's a system that does the whole world. So it did try to figure out where the Colorado counties are and threw it somewhere in the world. That's why when you look at the other one, it's in the middle of nowhere, somewhere in the world. Now let's fix that. Also, it's not only the location, the size is messed up. Because when we do projection, we project location and we also project scale. Because we have a completely different system for projects. Now let's fix that, and that's the question number 5. You probably answered the question. Where did it throw Colorado states?
Huh?
Where?
Southern California. Put it in California.
Yeah. Near Disneyland, right?
And then we went to after Hawaii after that.
So if you activate this one, yeah, put it in Russia, right? Poland, China. Okay. Now question number 4. Provide a snapshot for the new location and paste it on your Word file. Now let's fix the problem. So we're gonna fix the problem from the root now. We're gonna fix the data. So when you go to ArcToolbox, use something called Geoprocessing Tools. All of us can drive a car, but very few of us can change the transmission of the car. It's exactly the same thing we're doing right now. We can view a map, but very few of us will be able to fix the data, and that's what we're doing right now. So to do this, guys, we want to define projection to fix the coordinate system. And we don't know. Usually we go to this, like we tried to do last time, we go to the metadata, try to figure out the guide we created this data set, which coordinate system to use. And I have to have some kind of informed information so I can change it. So I'm telling you, you're gonna use here the Albers equal area conic coordinate system, and then let's answer the problem. So first thing, before you do anything, you can now remove the 2 counties from the map, because we're going to create a new data set with new projection file. And now let's go to the toolbox, to the mechanic here, which is again, remember the red fishing box. Now let's use another option here to define the projection. We're not doing the projection ourselves. Adding projection data to this file. So when we plot it, it will go to the right place. So let's do this again. Remember where we did all the projection and all the coordinate system work? You remember, guys? I'm going to go here to data management tools. I'm going to remind you again. And projections and transformations. We did project last time. The one above it is project. Before we start doing this, you're going to find something called batch project. You have tons of data sets, huge layers. You can do a batch of them, change them all together. And that's the option here called batch project. Okay, guys? You can create your own custom geographic transformation. Create your own, and this is very, very advanced when you have your own transformation equations and you can create this. So we're going to just go ahead and work on these three things. Data spatial reference, define projection, and project. And in our two labs, we did these two. So let's define the projection. So what's the input data set? It's my Colorado counties. Add. So that's the input data set we need to define the projection for. It's unknown. It tells me it's unknown. I don't have any coordinate system for it. So I'm gonna go here. And now let's look for, let's read this. So it's Albers equal area conic. When you hear the word conic, confortal here, it means that it's a projected system. So you go here, it's not there. Let's search for it together. So I'm going to go here to projected. You notice here we have state plane, we have world, we have UTM, we have world, sphere based, we have different. Let's look for continental since it's very related only to the US. So continental, North America. And let's see if we find it or not. So here we have Albers equal. Is it there? Mm-hmm. Yep, USA, contiguous Albers area conic. And then click OK. Then click OK. So now it is defined. Let's now throw it again and let's see if it works or not. So it's the defined projection is successful. Once you see this green tick line here, and let's now see if it works or not.
Is that the one?
So your results should look something like this. All I did is I defined the coordinate system as for whoever created this layer, you wanted to do it. We just got the information. We have now a form decision that we did, and we just defined the coordinate system to be this.
What do not show up?
Say again?
Not in. Like that maybe.
Show me the coordinate system for Colorado counties. No, not
Oh,
this. The coordinate system, you get it from the catalog. Right click, properties. Yeah, you use here or wrong. You use 1983. Here you as you can see here, It's looking for an Albers equal area code. You put it in a different coordinate system. All you need to do is just go ahead and toolbox again and define it again. So this tool, guys, overrides and fixes the coordinate system information for any data set. Here I'm not talking about layer, I'm talking about any data set. So guys, answer now for 6. What are the two coordinate systems used in this? Well, they're written already there. Are they projected or geographic? So for the USCS and for the UTM, are they projected or geographic? What are the units used in these systems? You can just look here in the map, look at the units, what are the units used for each? And what is the underlying ellipsoid and region used for each? What's this question mean? Every projected system comes from an ellipsoid. In other words, every map like this, it's either a cylinder or conic or whatever, it comes from the sphere or the ellipsoid that so it's called an underlying ellipsoid. So any projected system comes from a geographic system. So the answer for these two systems you have in this map, what is the underlying ellipsoid used? Yes. Question?
Did we have inverted cloud or what was?
And also here, what's the new data and steroid used for this specific kind of data?
Projected geographic, that's the right.
What is the what's the steroid used? So now let's get the part. That's the data, and that's the steroid used. And the other question we get from Windows Explorer was the new extension file that was missing. Remember last time, Colorado County had one missing type of file. Again, we discussed one type of file, which had now the information. So this geoprocessing part, it added a file to your data, to Colorado counties, and to remind you, so if you go to Windows Explorer, there's a new file. All files are updated actually because they're linked to each other. But there was one specific file that was created, and we answered this question last week. Okay, guys. By this, you finish the coordinate system. I have actually another question that I was trying to give you today, and then I thought, well, no, let's switch gears to something more lighter and easier and beautiful to produce. And this is where the new exercise. So let me give you a break. But before you go to the break, guys, you're gonna find a new link, eCampus, for exercise 7, or lab 7, I'm sorry. I have also a copy for you. So there's a link to the zip file. The zip file is big this time because we have raster data. So whenever you have raster data, expect a heavy, big file. So I cannot put it in eCampus. You're gonna find the link to it. Download the zip file, extract it, and let's just give you like a 10-minute break, And then let's start working on a touristic half of Florida with all the nice diving areas. Or south of Florida. Everything okay?
No,
No, why no?
it was on off.
Go back to the map. Right click on each of the frames. Properties. All the information I'm asking for is in this field. If you scroll down, you can be able to do graphic and the graphic system.
Good bit of Nick GIS got. Jason Barber.
Nick sounds familiar with a lot.
No.
Distracted.
Yeah. Alright, fix it. So, right click on the, right click. It's. Click on, let's go back to that.
Here?
Look right there. Yes, okay. Right click that. Right click, what is it? Extract all.
Okay, let's
Where
start.
you want to put it, per house.
I know it looks long,
And then
but it's beautiful. It's an easy, beautiful map. So let's start. So you are a graphic designer creating a marketing product for the Florida Commission of Tourism. You're not highlighting the Florida South Atlantic coast and the Florida Keys, which I hope I can go sometime soon when this is over. Will be printed in a brochure for prospective coastal tourists and scuba divers. And here comes the question I want to ask you guys. Can anybody tell me what does, especially if you know English well, what does the word cartography mean? Hmm?
Is it map?
Yes, map making, but we're making maps. When I can see you are a cartographer. You're an engineer or a GIS expert, but when can I say you are a cartographer? So yes, you're right, it means map making, but it has a different aspect to it. Anybody knows?
An accurate one? I mean, you can make a map, but it not be anywhere close to what it's supposed to be.
No, has nothing to do with accuracy at all.
So
Actually,
maybe I'll say so.
Actually, accuracy can be much, much less when you are a cartographer.
Are you just trying to make really nice maps?
Yes. Art and philosophy of art of making a map that will not only look nice, but looks best to your audience. Anybody here went to any theme park?
Nope.
When you go to the theme park and you get the map of the theme park, do you see an exact, accurate map, like Casey was saying? No, you find the coaster of not very accurate, but it gives you an idea. Where is the coaster? Where is the this and where is that? So I'm going to write you part of the definition. I'm going to complete that. So cartography, and that's why I told you to switch gears today a little bit from the engineering part. It is the field of study. It's part of GIS, but it's the field of study devoted to the, and that's the word, first word here, the art and science of, like you said here, map making. So it's map making, but here we little bit talk more about art before we even talk about the science. So it has a science with it, and it also has an art with it. A vast subject focuses on two different things: the design of the map, the design philosophy of the map. Again, when we're talking about a map for a museum or a theme park, it's a little bit different. You find the dinosaur bigger than the park. So why? Because your audience is a kid who wants to go and then figure out where is the dinosaur. So he's gonna go and say, okay, I want to go there. So it's not accurate at all, but it has an art to make it look attractive and make people excited about going to the theme park. So here, focus on number one, color theory. Choosing the right color. Here we're talking again about marketing. So that's why this class is amazing when you talk about entrepreneurship. Here, color theory and also design philosophy. Of your spatial accurate spatial information that we do as engineers. according to the map objective. So it will depend what you need this map for. Again, if you need it for the park and you want it to fulfill this function. If you want to make a map to teach students in high school, you do it in a specific way. If you want a map to show the mines in West Virginia, it's a totally different audience and totally different function. So this is the art of cartography. How can we use colors? How can we use the representation of the map to best suit the objective and, more important, my audience? Okay, guys, that's the meaning of the word cartography. We use font, we use colors, we use icons that will best represent the shape of the map. So, today we're going to do a little bit of cartography. We care a little bit more about how it looks like at the end. So, and your target now is scuba divers and tourists that come to Florida. And the map will need to look really delicious. That's exactly what I can say. It needs to be looking delicious to these guys who come for scuba diving. You want to tell them, yeah, there's a wreck here, and you want to go and dive there next to the sharks. So let's create something like this. So, using the data set provided for Lab 7, available on your webpage, we did that already. Let's open the EX07A map. And then let's add all the feature classes in the geodatabase that's called Florida. Let's do this. So I'm gonna go here, and this is the only thing I'll need from our catalog today. So I'm gonna go here under data. I'm gonna find a Florida geodatabase, and all the vector I have to do it one by one, or you know what? Not even without our catalog. I'm gonna add data like this way here, because I want to add it all together. So let's use the add data to save some time. So I'm gonna go up here to Lab Florida, data, geodatabase, and I'm using my control button here to pick all of them. And add. Okay. Now let's zoom extents. We're going to talk today about zoom extents. Zoom extents, you're going to put some extents to where the map will zoom once you click on it. It gives you zoom everything. That's the other way of defining zoom extents. So it's the globe next to this hand. This is called zoom extents. So it shows part of Georgia, Florida, Louisiana, and other neighboring states in Florida, and also the ocean. And you notice here, ArcGIS or software here is not a cartographer. It puts really ugly colors together. It looks like a bad Christmas sweater. Okay, so let's fix that and let's create a brochure. So let's start now. Yeah.
Okay, well, your catalog, you can try about that.
What you got? You went. Okay. Okay, guys. Now, using the following table, I'm going to do one with you. I'm going to let you do the rest. We need to do some name changing and symbology for all map labels. So I'm going to start with, let me start with one that has here. Let's start with Highway 1. So I'm gonna change Highway 1 to US Route 1. So how to change the name? Double click slowly or right click and change the name in your properties. So I'm gonna do this one here. I'm gonna do first one, right, double click slowly. And the second one here is called US Route 1. Let's do it for another one here. The bathymetry lines. I'm gonna change this. So right click, properties. And in general, I changed the layer name into, let me see here, ocean contour lines. And I'll let you guys continue changing all the names for the whole layers, something that will appear in your brochure as part of the map, when you put here the legend for this map. Once you're done, let's come to the next item, how can we change the colors. Okay guys, now let's change the colors of the border line or border color, the border width, and the fill color. We have three types of layers. We have points, we have lines, and we have polygons. Here. All of the lines and polygons, we need just to change the colors, again, to look nice. So, can I have your attention please guys? So now we want to change the colors of the lines. So let's go first one here, for example, Highway 1, which became US Route 1. I want to change the line color to Mars red, and I want to change the line border width to 1.5. That's the easiest thing you can do. So I click on the line icon below the name. And this is where I'm going to fix everything. So here I want to change the color to something called Mars red. See this color here? Open this kind of color palette. And if you put your cursor, it's going to tell you the name of the color. So here we want to go to Mars red. So which one is Mars red? This one is Mars red. So I click here. This will be Mars red. And the line border width to become 1.5. Okay. I'm going to do it for other one with fill color. So I'm going to do it also for a, so it's going to add, you can see here, highway, one of the highways is turned red. That's covered with cities. We're going to fix the cities. Again, we're doing some cartography here now. We're trying to make our map look professional for our audience. So I'm going to do, let's do here the parks, state parks. No color for the border and Macau green for the fill. So for the state parks, gonna click on this one here. So the fill color is Macao green. Here it is. The outline color is, or the border color is none, no color. And that's for the state part. It might not show because the order is still very bad. We need to fix the order as well. We just put it directly from the file, but we need definitely to fix the order. Let's also do the southeast, which is named now Florida background. So southeast here. I want the line border to be gray 20%. So I'm gonna go here, gray 20%, here we go. And the fill color to become light apple. And the outline width to become as it is, 0.4, click OK. So this is the southeast. And you go ahead, guys, and fix all the colors and lines and borders with all these layers. I'm giving you all this so you can feel comfortable changing all the colors for all the layers. Okay, guys, now let's change a little bit of orders. Number one, change order of the ocean control lines layer so it does not cover or interfere with the coast boundaries. Again, we're dealing here with layers. You don't want this really ugly contour lines to interfere. So when I put it below something. So let's change the order of these green. In my case, it's green. For you, maybe purple, other color. We're going to change the order so it does not interfere. You can see it's interfering with the coastline. So we're going to fix that. So all you need to do is just go here, and this ocean contour lines, let's put it somewhere that it still shows up, but we give focus now on the line. It's not above the line, it doesn't interfere with it. So that's the first thing. Also make other layer arrangements so to show the Florida lakes and state parks. So let's now make our points and lines, then polygons, but in a way that polygons do not cover important things well. So I want now for my polygons here. So this is the coast and then the state parks. So I want the state parks to be above everything here. So I'm going to go here, state parks. And the lakes. And then the counties. No, let's the coral. I double click. After we finish this class, guys, let's zoom as okay, guys. Although lines are typically placed on the top of polygons in drawing order view, where did you locate the ocean contour lines layer? Why does it make sense to this layer in that location? Why did we need to change the border of Florida lakes? Once you finish creating the map, just highlight this question here and answer it in italics there. Just when you put it, don't forget to answer this question. Why did we change the order for this specific contour lines? Why is it best to put it this way? And also, why did we need to change the order for the takes? Okay, guys? Then we get back to this zoom extends. Zoom extends, as I told you, if you click on it, it's gonna go and figure out all, or just go to the whole southern part, southeastern part of the US. If you guys wanted to change this for this specific case of map of South Florida, and this specific case of zoom, I want to create here zoom of 1 to 300,000. Let's create a new focus on the map to show the shipwrecks. Sorry, change default extents to 1 300,000 focus on the map to show the shipwrecks around southern Florida and the East. So let's do it together. When I click here, zoom extents, it takes me here. Takes all this map. I want the zoom extents to be closer, which is the biggest zoom I can get. When I click on this button here, zoom extents. To do it, it's so easy. You go to layers, properties, and above this coordinate system, you're going to find called extend. Sorry, data frame. So under the tab called data frame, these are the general options for data frame. And you want to make your extent to be the default here. You want to specify your extent. So before we do that, we need to create our extent view. So I'm going to go here and do this, the 1 to 300,000. No. Yeah, add a 0, guys. I'm sorry. Yeah. Add a 0. 1 to 3 million, 1 to 300,000. Add a 0. And you can now start panning till you show whatever you want to show here. You want to show the Keys and southern Florida in your map. And this you want it to be the zoom extents thing that you want. So now let's get back here to the zoom extents. I'm going to go here to layers, properties. And click apply. Okay. I'm just checking everything looks good here. Frame. Yep. Click apply and OK. So this should be now our zoom extents. Now let's move to the next one here. Can you change the name of this frame instead of layers? Can you change it to Florida Living Sites? Now let's change the colors of the layer that we called state parks. I haven't changed the name, so it was state park. Let's look at this layer because this will be the main color in our map here. So open state parks attribute table, and let's examine one part of my attribute table. And let's examine public ACC. I'm going to tell you what's public ACC. So this public ACC, what do you think it represents, guys?
money get in?
Huh?
Looks like something to do with money.
Yes.
Public access.
Public access. So it shows two options in this one here. One is called open, fee required, open, no fee required, and maybe there's a third option. So either it's open or not, or probably closed. So these are the state parks things that you want to make it clear for the tourists. They want to go ahead and go to these parks and tell them which one is fee and no fee. So this is the public access field. Then let's create a color for each category. We did that before, guys, remember? Using same field as follows. Fee required using Esri sun color with no outline. No fee using Esri green color with no outline. Update field name to public access indicator of properties. So let's do this, guys. So in state parks, we need to change now the symbology of that. So it can do different colors for different state parks as per the instructions here. So I want to gonna right click or double click on it, and after right click, click on properties. And under symbology, we're gonna, if you remember, we did categories, because we have qualitative category that we need to specify it. So here, let's create any one you like. Let's do it a green. And let's add all values. But we need to do it as per the public access. Now let's add all values. So we have here open fee required or non-required. And let's do the following. For fee required, use Esri sun color and no outline. So for open fee required, double click on the color palette there, and let's choose sun and with no outline color. And for the no fee, we need to use Esri green color and no outline. So that's the Esri default colors and no outline. And once you do that, guys, it puts here the three options you have for color. Let's click OK. So now all the parks you have here, my color won't be like you because I didn't change all the colors on the table like you did, guys. I see some beautiful green parrot-like colors here. And then the second thing you want to do is this guy here, public access. Let's change the name into public access. Sometimes this is very important for us, especially when we add the legend on the map. It will take whatever name is there and will put it in the legend. So it's very important for you to put it in a name that you can read. So I'm going to change this to public access, like we did in the. And let's also change this into open fee and open no fee or free. So open fee, open free. Okay, guys, any question? Remember, guys, when we did this selection and we filtered out the cities that have small population, we're going to do the same here, but with a different way. And you want to filter out the small towns because probably a tourist coming to the map, he's more interested in the big cities where you're going to get his gear and find hotels. So the question here is use something called a definition query to limit display of cities 100,000 or more without deleting or adding any data. We're not doing anything. It's just a query to remove the cities that have less than 100,000 people. Then add labels. We'll do this. So there are different ways to do it. You know already one way. I'm going to do it with another way. So for cities here, I now want to just remove all these smaller towns and smaller cities. I'm going to do it in a different way. I'm not going to do any selection today. I'm going to do something called query. So under properties, and you notice now, guys, I'm giving you one by one the different tabs of the properties. We use symbology, we use general, and now we're going to use something called definition query, which is very similar to the selection, but it's a faster way to symbolize and show the data. So here, definition query, you can see it. It's number 7, I guess. So go here to definition query. Let's create a builder for the query that will show the data as we want. Exactly like we did before with this kind of calculator. So here we can, these are the different ways we can do it. We can use different fields now to figure out or filter the cities that are less than 100,000. So let's figure out what are the different values we can use. So here I have the cities. I have something called population range, population 2000. And these are the two ways we can use. I'm going to use this first, the population range. If I don't know what does it include, I can go to the table or I can go here and get the unique values. So these are the values where the field is. So you notice here I have cities with 10,000 to 50,000 and so on. You have different 50 to 90 to 100,000. So we want now the cities that are greater than 100,000. So we're going to create this calculator thing. Remember we did this before? So I want to here say that my population range is greater than and equal to this guy here. I'm just double clicking. And or the population range is greater than or equal to 250,000 to 500,000. Or my population range is greater than or equal 500,000 to 1 million. And click OK. Let's look before we click OK. Let's do apply and see what happens here. Say again.
We can't check it fast enough. We can't run the safety project. We can put it back up there so we can look
Sure.
at it for a second.
Sure. And I made a mistake, by the way. So I'm gonna have to fix it back in because it's a range. Why did I not read it? So I'm gonna just do directly equal. So this my statement is wrong. So let's fix that. So I'm gonna go here again to the query builder. And instead of this guy here, I'm gonna delete and put equal. And this one to be equal. and this one to be equal, and click OK. You still have a look at it? So I created an expression that tests what cities that have the same attributes here. So I've used here this kind of range. So the range, I will show if the range, population range, is between 100,000 to 250,000, and or the range is between 250,000 to 500,000, or the range is between 500,000 to 1 million. Let's see if it works now. Before it didn't work because I made a wrong statement. Let's click OK. Before I close it, let's click apply. And here it is. So probably all the cities. Let's turn off the shipwrecks because you don't want to get confused between them. So these are the cities. Not too much cities that are more than 100,000 people. Probably Orlando, Miami, Tampa, maybe other cities around.
Mine still says there's an error.
What error?
Yeah, that's hard to master on here.
No, it's oil statement was used. Right, statement was used for offering.
Oh, I had it the whole time. I thought it was dark. Oh, it's dark for the room.
Yeah. He hasn't changed his colors. Like he has here for us. His colors are a little bit different than ours, but he hasn't changed.
No.
Oh, yeah, I got stuff
Yeah.
dark.
Yes. I mean, you do need to color.
Well, I changed that one. What is that, county?
Like programming.
Florida County, especially
Errors. Let me do this.
Florida counties are
So
great.
how do you
10%. That's the line.
I'll put it again on the screen. Maybe you can see what the one now.
Right, 10%.
Yeah.
Okay.
And then it's the fill color. What do you mean that's the fill color? Fill color.
Is there a second easier way using another field? Yes, there is. Try to figure it out. There's a definitely easier way.
It says line water color and this is fill color.
Oh.
Yes, two things.
Good, because I don't see any cities.
I'm gonna go to Florida. Go there and work. Let's go there and work.
Yeah.
What's the red one? What's the red one?
US route one.
There's only one US route goes through there.
Yeah, I think it's just the route number one.
There's a big, I don't know. Well, you can run down the whole East Coast there. Looks like a big butthole right there. Feel like right there.
Well, it sort of is.
I mean, you got that one pond lake right there. It looks like a sore thumb right there. It's got things so bad.
Yeah.
That one, or it looks like a bubble.
What?
Looks like a bubble. You like that lake right there? All the veins are going to that hole, and it's like a sore or something.
Okay, so is there an easier way, guys? Yes, there is another easier way. Is there a third way to do it? Yes, using selection, like we did last time. So these are 3 different ways to do it. Now we need to change the symbols of the cities to Esri style circle 3 with size 10. Let's do this. Remember, we changed the icons of other layers, but we didn't do the focal points. So for cities, go here. Let's go to, let's see here, Esri style. So that's Esri style, circle 3. Circle 3. I'm just picking up the name of the style of the point. With size 10, let's change the size to 10. So if you have the city still there, I'm going to show you probably. Okay. Now, here comes another, let's now show the Rex and And now let's give it a wreck icon. We did that before, but I want to show you something extra here. So for the shipwrecks, I'm going to turn it on. You can see here, these are the locations of some old ships that are wrecked, and divers like to go there to see the reefs down there and the fish. So we want to give these divers a nice icon that shows that. So let's do this together. So I'm going to click on the dot under shipwrecks. And if you search here, you won't find any shipwrecks. These are the main styles. If you want to click on style references here, and you can turn them all on and look one by one and the best shape of shipwrecks. That's the second way to do it. These are all the different, we call it styles of icons that we use depending on your use. If you're in the Marine, if you're in the Army, if you're in the zoology, if you're in different parts and you want to create maps, you're going to find the style used. We as transportation engineers, we use specific styles with all the highway shapes, interstates, interstate shapes. So we have icons for every kind of discipline. Or another easier way is just here in the search, you're going to search all these styles, and let's search for the word Rex. And make sure you selected on all styles. You're going to find different Rex under ArcGIS Explorer. And let's exactly choose this rec here. If you go down, under Civic, you're going to find two recs. Pick one of them, one you like. Click OK. And now, see now the art of cartography, how it looks like. Now you have it's getting prettier. You probably it's much prettier than I am because I skipped something. Say again?
How do you add all the stars? How do you determine there?
How did I do that?
I want to do, I don't shoot. You know that triangle right there?
Very top there.
Ain't it right there somewhere?
Oh yeah.
That's a great question.
Yes.
For the guy. Yeah, what about the? That's why there's so many ships, there's a triangle.
Okay, guys, remember last time when we talked about layer files, when you create a file that you can send to your friend with just the shipwrecks. So let's create the layer file from the shipwrecks so you can send it to somebody. The layer file is the one that has all the new styles and icons and font and things that you changed without, remember when you added data, the computer made it really bad and added default colors and shapes. Here you want to add these shapes, you give it to your friend. So let's create a layer file from the Rex. So that's very, very straightforward. Right click, and I create a layer file. So I'm going to save this as a layer file. And let's call it shipwrecks. Let's just make sure you put it in the right one here. In my data, shipwrecks layer, it's already there, so yes. So I now have my shipwrecks. So if you send it to your friend and he has a map of Florida, sometimes I think you can also put it directly in Google Earth. So if you have this layer file, you can put it anywhere you want, and you can send the information the same way you created it.
And save as a
Alright, we started with what?
Okay, guys. I'll let you do this one because we have done this 2 labs before. Symbolize the ocean contour lines layer quantitatively. So you want to do it quantitatively based on the depth. So these contour lines gives you the elevation of the bed of your ocean. So you want to just symbolize it quantitatively based on depth measurements in meters. You want it light blue for shallow lines and darker blue for deep lines. Can you do it? I'll do it without talking. I didn't even put my mask on so you cannot hear me. And You're gonna follow because you already know how to do it. We did it 3-4 times before. Beautiful, huh? Also, I'm going to use the same way. I'm going to use graduated symbology for the cities layer to symbolize cities in Florida based on their population. So it's not going to be only 10 size 10. I'm going to change it to tell me how population is. So I'm going to do it also without taking my mask off. Okay, this step is not in your assignment. Let's do it together to show you something else which is really cool. In my case here, I have my counties in blue, and below it, I have the nice green color of the whole Southwest. I didn't change all the colors intentionally for that. But I want to show this green color. So I want to create some kind of transparency to this blue counties color. Can we do this? And you're going to have this in the homework. Because in homework, you're going to deal with the 2 layers that are rastered. Exactly the same thing, with even fewer options for raster. So I'm gonna do this layer which is above the southeast, below it's the green layer, and this is blue. I'm gonna create some transparency to it. Let me show what I mean. So if I go here under counties, again, properties, I keep going into the properties again. And before symbology, there's something called display. And display tells you anything about how this layer is displayed. You're going to find something called transparent with 0% transparency. Let's change this percentage to a bigger number to show a little bit of color of what's below. So I'm going to show you that in a second. So I'm going to change this, and I can test. I can put it on the side and test. Let's make it 40%, and then apply. So now it gave some kind of transparency. It shows more in the raster. I'm just going to show you the meaning of the word transparency. And the more transparent it is, when it reaches 100% transparent, it's like this plexiglass. It shows exactly what's behind it. But when I have another percentage, it's a mixture of the two colors. So the lighter color of blue in my case, and the higher color of blue. Okay, guys? Okay. So when you guys, in your homework, you're gonna use the same map, so we wanna save this map. In your homework, you're gonna find here three layers of raster. Let me show you one of them. Cancel. And the raster has now, that's why it was a big file. It has now pixels of different colors that shows different things. So this will be your homework. You want to discover, you're gonna work more, hopefully in the last few labs with rasters. But I wanna focus a bit more on the data. I have lots of that, but if I had the time, I would make much more labs because RJS has a lot to offer. So guys, add all your map items like we did before, more size, scale. Again, keep in mind that you are now engineers / cartographers, and then create a PDF, and you can now upload your exercise. And I'm done here.
Oops. Yeah, it's Spanish. Yeah, I'm working on it.
Later on, we're going to add really beautiful professional labels to this map that shows exactly ocean, cities, and so on. So this map is still work in progress.
There you go.
Yes.
What do you do? Add all that legend stuff?
Accidentally added. That's the thing.
You think say that in all?
Same thing ever since.
Wasn't
Heck,
it?
it's the-
We gotta add a legend and all that other crap.
It's an add-on value.
Okay, go back to
Legend.
But yeah, we don't like it on that.
double click on the name or right click on the
Change the text in one. Change the text in it. That. Order? Yeah.
Go back to the features. Just click OK.
Okay.
Yeah, so, and then
What a man, what a man, what a
start again, and then if you're, no, you go again.
I wouldn't like to do that after it's the five. Say yours is five.
Not responding.
Graduated, Josh. She turned it into an application the next day.
Nope.
So I went here.
Oh, yeah, they want to get comments.
I wanted to change that to.
Nope, you gotta use it.
Yeah, I think I did. It's five. That's right.
Yeah. Where did you look this? Where did you put it? Where did you put it? Again, this is what makes sense to do later. to this layer and that.
What?
I guess they put this layer.
It's that word number.
Why did we need to change the order?
I would have been walking around there. Oh, I'm gonna. I know.